Okay, welcome to 4-6, finding all the zeros of a polynomial function. I am going to do page 199, numbers 1 and 4, and then you're going to do page 199, numbers 2 and 3. All right, now 4-6 is going to look really overwhelming, but don't worry, it's actually just an extension of 4-5, where we found in 4-5 just the real zeros, so the x-intercepts, and 4-6 we're also going to find the imaginary zeros, because sometimes the zeros don't exist in the real world. Okay, so for number 1, the directions are actually just find the solutions, and if you look at page 198 at the fundamental theorem of algebra, it's a lot of words, but it basically, one big thing of it says that if you want to know how many solutions you need to find, just look at the degree of the function. So for number 1, it says how many solutions are there to x to the 4th plus 7x squared minus 144? Well, the answer is 4, the degree of the function. So the answer to number 1 is 4. But we're going to go one step further because practice makes perfect. And we're going to find those solutions. And this one's pretty easy because it's in the quadratic form. I only need to think of two numbers that multiply to 1 to 44 and subtract to 7. Well, that's not so bad because it's 16 and negative 9. 16 and 9 multiply to 144, and 16 minus 9 is 7. So, here's a hidden dots problem. I have x plus 3, x minus 3. All right, well, if I set it equal to 0 and actually find these solutions, well, this is a 3, and that's a negative 3. So I have plus or minus 3 as two of my solutions. How many do I need total? 4. All right. And for this one, well, they're going to be imaginary because I'll have to set x squared plus 16 equal to 0, and I'll have to take away 16 from both sides. And when I square root both sides, I get x equals plus or minus, there's a negative there, so I, and the square root of 16 is 4. So here's my other two. It's going to be plus or minus 4i. So how many solutions are there to this polynomial? 4. What are the solutions? Plus or minus 3, plus or minus 4i. Why don't you now go to your calculator, graph it, and see what it looks like. I bet you'll be able to find these. See if you can find those on the graphing calculator. And if not, why not? Okay? All right, on to number 4, which is going to require a lot of math. So I need to find all the zeros, find all the solutions of this beautiful polynomial, x to the 5th minus 3x to the 4th plus 5x cubed minus x squared minus 6x plus 4. So first of all, I know I'm looking for 5 solutions. Real, imaginary, I don't know yet. So what I'm going to do, because I realize I can't group it, I can't factor it, besides grouping, I'm going to go to my graphing calculator. I'm going to go ahead and plug it in. All right, I know you can't see it very well, but go ahead and plug it in, check your signs, check your exponents, graph it. You should get something like this. And then I'm going to go ahead and second trace, just like we did in 4-5. I'm going to look for some zeros. So it looks like one of the zeros is at negative 1. So I'm going to take my negative 1 and I'm going to put it in the box. And I'm going to do synthetic division on this polynomial. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and add. Remember, the remainder is 0, which means that negative 1 is definitely a solution, and we did the right thing. Woo! All right, so I have a new polynomial. And technically, it doesn't really matter, but this was x to the 5th, so this is 1x to the 4th minus 4x cubed plus 9x squared minus 10x plus 4. Can you factor that? I can't. So what do I need to do? I'm going to go back to my graphing calculator. And I'm going to look to see if there's any other pretty nice integer solutions. And in fact, if you do second trace, and you go ahead and you try to see if 1, it looks like 1, is going to be a solution, you'll find out that 1 is actually a solution. And the calculator might not be accurate, but you can round to 1, 0. So mine's taking a while. But, there it is. It comes up with basically 1, 0. So what do I need to do? I need to now put 1 in the box and do synthetic division on this, just like we did in some of the harder problems from 4 or 5. All right, so make sure you have 1, -4, 9, -10, and 4 copied down because I need to use a new whiteboard. All right, 1's going to go in the box, and my new synthetic division is from my answer to my old synthetic division problem. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. 0's in the box, which means 1 is also a solution. And now this was x to the 4th. I'm left with x cubed minus 3x squared plus 6x minus 4. All right, so now I have x cubed, which means I have 3 more solutions I need to find. But I have a huge problem because I'm going to try to group it. And I take an x squared out, and I get x minus 3. But then I take a 2 out, and I get 3x minus 2. And these are not in common, which means that it is not groupable. So you go back to your graphing calculator. Now this we're going to have to talk more about in class, so just trust me for now, but during class we'll talk about why it works and how to look for it, and I'll give you some tricks and some rules. But go back to your calculator. Does it look like there are any more x-intercepts? And the answer is no. It doesn't look like that. This is an odd function. It's positive. It's going to go up there. It's going to go down there. It's not curly queuing again. So what I'm going to do is I'm going to just pick 1. I'm going to pick one of the solutions I already used, -1 or 1. I'm going to pick 1. And I'm going to do synthetic division on this right here. Remember, this was the last answer I got from synthetic division. I'm going to do synthetic division again with one of my old solutions that I used before. Okay? So make sure you're going back to this line right here, 1, -3, 6, -4, and I'm going to write 1 in the box, 1, -3, 6, and -4. Okay? Doing synthetic division one more time, and I'm guessing that 1 is going to work. So bring down the 1, 1, -2, -2, 4, 4, 0. Good. 0 is my remainder, which means 1 worked again. All right? Now look, you might not get 0 as a remainder because you picked the wrong thing. Well, there's only 1 more to pick, so you pick -1 and you go back. Trial and error at this point. Really, you're just kind of hoping that something works. So 1 did work, and I'm left with x squared minus 2x plus 4. And remember, if you ever get down to this step, because we did so much synthetic division, and you're confused as what this exponent is, start back here. The remainder is 0, so there's nothing there. This is your constant, so it never has an x. This is going to have 1x, which means this is going to be an x squared. So if you're ever lost at what step we're at with what exponent the polynomial needs to be, just go backwards. Constant, 1x, x squared, and then keep going if you need to. All right, so I'm left with x squared minus 2x plus 4. This is something I can actually deal with. Can I factor it? Well, do I know 2 numbers that multiply to 4 and add up to -2? And the answer is no. So I'm going to use the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, why don't you copy that down while I get out another whiteboard that I have to get ready. So I'm going to continue the quadratic formula on this. 2 plus or minus the square root of 4 minus 16 all over 2. Remember, we have -1 as one of our solutions. We have 1 as another one. We have 1 as the third one. So -1, 1, 1, and we're looking for the last 2. So I was at this step on my quadratic formula, 2 plus or minus. You notice I just did 4ac from the last board to here. So we keep going. 2 plus or minus the square root of -12 all over 2. 2 plus or minus, let's see, there's a negative in there, which is an I. 12, what's the biggest perfect square? 4 and then 3. So what's the square root of 4? It's 2. Do I know the square root of 3? Nope. 2. And I have a triangle of simplification because I got a bunch of 2's right there. So 1 plus or minus
I rad 3. All right, so I have to collect all of my answers. I know that -1 was the first solution that I found. 1 was the next solution that I found. I used 1 again. And for right now, yeah, you're going to write it. I'll tell you what to write later when we get to class. And then finally, my last 2, right? Plus or minus means that there's 2 right there. 1 plus or minus I rad 3. So for the polynomial function for number 4 that started out with x to the 5th, we found all 5 solutions. -1, 1 twice, so that's 3 right there. And then 1 plus or minus, that's 2 more I rad 3. All right, a lot of work. Take it step by step and work your way through it for numbers 2 and 3. For number 2, it does just ask you to find how many solutions there are. That's easy. Go ahead and try all this crazy math right now. That way you get the practice and you can see how synthetic division and factoring work together. All right? Good luck.